Welcome back to SAT Math Question of the Day. Here's our question. Please try it. Pause the video, come back, and we will do it here. The cottonwood tree had a trunk diameter of 2 inches at the time it was planted. The tree had a trunk diameter of 22.24 inches X years after it was planted. The equation 0.64x plus 2 is 22.24 represents the situation. Got it. Which statement is best interpretation of that? Well, we already know that's the growth rate, yearly growth rate. So let's see. Let's read them all. It's important to read them all so we choose the best answer. The total increase of the trunk's diameter X years, no, it's a rate. The trunk's diameter X years, no, it was a rate. The maximum trunk diameter of the tree over its lifetime. The 0.64x. Oh, I misread it. I just read it as 0.64. Oh, okay. Sorry. The total increase of the trunk's diameter X years after it was planted. Yes, that's the answer. I thought it were only asking for pink 0.64. Okay. Oh, so yes. But I am shocked. That they didn't put in as a distractor what I would have written if I didn't read that carefully. The yearly increase of the... I know. The yearly increase of the diameter's trunk. Wow. I can't believe...
Okay, I think you were misled by declaring the word rate.
Yes. I was.
You said the rate. It is the rate.
Seth.
You said they are asking for the rate.
Yes, because
and then you said the total increase in the trunk's diameter X years after it was planted. A is not the rate.
I know.
And that's why you excluded A.
No.
Your mistake was that instead of saying that 0.64x is the rate times the time, you said that the thing to be interpreted was the rate.
Yes, that's because I misread the problem. I didn't see the X. I didn't know.
Okay, you didn't see the X.
That's
okay.
the problem. The problem is that
you didn't see the X. All right. Either way. So what's the lesson?
Read the question carefully and don't be a schmuck. read the question carefully. But yet again, you didn't. You interrupted me. If I kept reading, I wouldn't have found a rate, and then I would have been perplexed. You would have seen me say, "Wait a second. You don't have the answer," and then I would go back and I'll say, "Oh my God, I didn't read the question."
Okay. D.
Okay.
D is the rate.
The total increase of the trunk's diameter each year. Yeah, I guess that is the rate. Yeah, the total increase of the trunk's diameter. Yeah, I guess that was a rate. Yeah. So I may have said that. Ooh. So, lesson to be learned. Very often you make mistakes on the SAT, not because you don't know the math, but because you don't answer or read the question carefully. This happens to everyone. I bet people who are studying this happens to you and you feel really bad. Wow, yeah. So you've really got to slow down and read the question. You can know all the math in the world. Not that I do, but you can know all the math in the world. You could still get the question wrong. Yeah. Wow. So they really were making sure you could read the question and know the math. Maximum trunk diameter of the tree over its lifetime. No, that's obviously not it. Yeah. So this question is both understanding linear growth, a linear equation, and also being careful to read the question. Yeah. See, Seth initially thought that I saw the whole thing, and I was answering, and I was calling that a rate. No. It's interesting. Usually they would. Well, I guess they put this 22.24 as the final answer, as the final output of that function. Y is equal to 0.64x plus 2. So what else do you have to say about this, Seth? I'm sure you have something to say.
Okay, X is an unknown.
X is the number of years. X is in unit of years.
No, it says the tree had a trunk diameter of 22.24 inches X years after it was planted.
Right.
Right. So this is so that's why X is not a variable.
Oh, X is not a variable? No, I guess not.
Yeah.
Okay.
Yeah, X is in other words, we're not talking about. They're not giving you a function that tells you the tree's diameter after any choice of years.
Oh, I see. In other words, just specifically
Yeah.
the number of years that it took to grow to 22.24.
Yeah. So this question is even though the data is available to solve for X, that is not what the question is asking for.
Right. Yeah. They're asking, this is a very common type of question on tests like these where they want you to interpret the meaning of something in a function or in an expression. What is the what is the meaning? Very common.
The question would have been the same if they told you the numerical value of X.
Yeah.
We could figure it out if you want.
No, it's okay. But this is one of the first times I've seen this question asked, which is, again, like, no do it, bad habit, where they ask you what the product is. Almost all the time this question's asked, they always ask, typically, you do a survey, you do a study of all these questions asked in the United States on all tests, okay? And you do a study. Most of the questions ask for just simply what is the 0.64x. It's so unusual to be asked what is 0.64 times x. I'm still disturbed by this. But Seth says, and we all agree, every question has to be taken on its own. Oh, yeah, every question has to be taken on its own merit. And that's really, it's a lot harder to do that than it looks. And instead, this brings back to what you said, which was very good a few days ago, that our brains are programmed to look at things and immediately make assumptions because that's the best way to survive in the world.
Yeah.
So.
Well, that's the way we used to survive in the world.
Okay.
That was a successful strategy for survival, and that is why we do it now.
Right.
Whether it will continue to be a successful survival strategy is a question for the future.
Well, first of all, it's a horrible strategy when you're taking tests like this, when the test taker people are purposely trying to put things in that appear to be one thing but are not. When you have people there knowing your weaknesses and exploiting them, you really got to be careful. But this is a very unnatural situation, taking the SAT.
Yeah.
But I don't know. I mean,
it's just a a question where the task is to extract the precise meaning of what the words are saying together with the precise meaning of the question that's asked, and then and then picking the words uh, that express exactly the answer that the question is asking.
Oh, right.
It's
So,
just, you know, it's
right.
uh,
So maybe when I start,
so I think the what we need to emphasize when people we read when we demonstrate doing these questions is to read the question slowly and clearly.
yes, and I think I will start doing that on today's Friday. On Monday, I will read the question slowly and clearly, not saying anything in between, not doing any editorial comment, just reading everything slowly and clearly. Good idea. We will start modeling this on Monday so that you can start modeling it and you can listen and see that I probably won't make as many mistakes like this. Okay.
Yeah.
But I'm sure you made a mistake like this in your life.
Yeah.
Yeah, of course. We all have. Yeah. Okay. So, first of all, calculator. We go through the 4 questions. Does a calculator help? This is a calculator section of an older test, previous non-digital test. Calculator, of course, doesn't help. You start with the guess as well. You have to read all the choices, really. In school, yes, it's not really different from a school test because very often on a school test you do get questions like this. But they may just ask you, yeah, you can get this on a school test. And the main idea, we were talking about the main idea, which for me, the main idea here is reading the question correctly. But the other main idea is the main idea that they were also seeing, as long as you read the question correctly, is understanding linear growth and what the components are in an expression that represents linear growth. And so the tree starts out at 2 and it ends up at 22.24. The difference is this whole term, and that is the total increase in the tree's trunk diameter X years after it was planted. And that is actually, in terms of linear growth, it's irrelevant it's linear growth. Right? It's irrelevant because they could have put anything in here.
That's right.
They could have put
anything.
So it's not even a question about linear growth. It's irrelevant.
Yeah.
They could have put anything in there.
They could have said Bill.
They could have said Bill.
Yeah.
That's right. So it's the main idea was not really linear growth, even though it looked like linear growth. Boy, did it look like linear growth. Yes, it's really just unpacking the terms, the meaning of terms in a algebraic expression or in a mathematical expression. Really. Unpacking the terms in a mathematical expression. That's right. What do you think of that, Seth? The main idea is really unpacking the interpretation of terms in a algebraic in a mathematical expression. Yeah. Boy, so it looked like it was linear growth. Wow. But it really wasn't.
Well, okay. They could have written what they could have written is 20.24.
Yeah.
Well, they could have written 22.24 minus 2.
Yeah.
Any of these.
Anything.
Would have the same answer.
Yeah, they could have put anything in.
Yeah.
Okay.
And they did. So actually, the 0.64 is not the rate. It is the average rate.
Yeah, right. Yeah, the average rate.
Average rate over the particular number of years in this situation.
Right.
And is who uh, um, it is you know not it's not apparent or even as unclear as there's no simple idea for it being true. It being true that
Yeah.
the diameter of a tree increases linearly with time.
Yes, because that actually doesn't make any sense. Because
I
if
thought,
you're,
yeah, it was
yeah,
trees. They first, we there's no information about about what the if there's a that there's a that's linear over any period of time.
yeah, actually, it really
And
makes no
indeed,
sense.
the grow the rate differs. It varies according to the season.
No, but not only that, Seth. Look, if you have a little baby tree that's in the center that's only 2 inches diameter, growing 0.64 is a huge amount compared to at the end of the time 22.24 growing 0.64 when it's a huge tree. It just doesn't make any sense. It would be like a baby. The growth can't. It doesn't make any sense for the growth to be the same when it's in terms of linear size. Go from two to
No, maybe it could make sense. It could make sense because it's a matter of how much a small patch uh, uh, grow, is displaced outward when the tree grows.
I guess we don't know enough
And
about
if
tree
the
biology.
patches at each patch, the same size patch, you might think that the same size patch behaves the same throughout the life of the tree, but it's not valid because we don't know how the overall conditions of life in the tree vary over its
No,
lifetime.
we're assuming constant conditions over the tree's life. Okay, just make that assumption. That's not. That's yes. That
Well, we could make it like whatever. The question is how true is this assumption?
no. Forget about these. What about this base? So you're saying that a tree can start out as two, and its first year grow a tremendous amount on a percentage basis.
Of course,
0.64 out of
of
two is a
course.
huge
No,
percentage basis.
if you've watched plants grow, that is what they do.
Yes, but when they're 22.24, they're not growing. If they're huge, relatively large, they're not growing at the same growth rate, percentage growth rate. That means the plant with this stupid plant would take over the whole world if it was growing at
The
0.64
height,
out of 2.
the height
This
is
is not
limited,
height, it's
but
diameter.
the thickness. No, again, it's at the beginning. If you've it's a matter of you look at at the ring structure
Yeah,
of a log,
right.
right? Uh, if you look at maybe true actually because if you look at at a cross section of a log, you see the rings,
Yeah.
and my recollection is that at least most of the rings are pretty much they vary from year to year. The thicker ones and thinner ones, but they just the thickness goes up and down. So they're roughly the same. Each ring is roughly the same thickness.
And that's my whole point. If they're the same
But then
thickness,
when the tree, what I've seen is that when old trees are cut down, the newer rings seem to be thinner.
that's my whole point. That's my whole point. If the percent, you look at the size of the ring relative to the diameter.
The size of the ratio of the width of the ring to the diameter steadily goes down.
That's my whole point. This model
Yeah,
says
yeah,
it goes up tremendously. This model says even when it's huge, it's still growing at 0.64. Oh,
yeah,
wait.
yeah,
Oh, I see.
yeah.
Even when it's huge, in other words, it's constantly, but, oh, I see what you mean. In other words, if it's huge, let's say 100 feet, just 0.64 is just such a tiny little
Yeah, yeah,
percentage. I guess maybe you're right. Maybe. Yeah,
yeah, yeah.
okay. Okay. Enough of this just useless conversation.
No, it's useful conversation because it tells a lesson that SAT questions uh, do not encode much of the world's knowledge.
Right. Yeah. Yeah. Okay. So I'm Joel. I have a PhD in mechanical engineering. It's been a long week. And my brother Seth's PhD in math. We're here to go over SAT questions. We try to do one a day. As you can see, we discuss the problem. We try to look at the problem from different angles. We analyze if we get the question wrong, why we get it wrong, which is what you should do a lot when you get a question wrong. You study and figure out why, so you don't make the same mistake next time, and then just learn from your mistakes. So try to practice as many questions as you can. Go to Blue Book, because now the SAT is digital. The SAT people offer an application called Blue Book where you can practice on 4 tests. And if you're weak on a particular subject, you go to Khan Academy. They have a digital SAT test that they partner with the SAT board, the College Board, and you could practice 20 or 30 questions per topic on the topics you're weak on. But practice, and learn from your mistakes, Okay, and then please give comments on our videos. We take them seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And I feel like I forgot something, but we meet every day, so whatever we forgot will come up next week.
Well, the email address is on the title page of this YouTube channel.
Yes. Okay, everyone. Have a great day. Hope to see you next week.